Okay, this is 1.3, represent function as rules and tables, looking at the practice problems today. Okay, the first couple questions here, we just need to identify the domain and range of the function. So remember, domain is the x values, range is the y values. In other words, the inputs are the x values and the y is the output. So for domain, we just need to list the x values, which is on this side here. So we're going to do our little squiggly brackets that represents a number set. So we got 0, 1, 2, and 3. And our range is going to be the outputs, the y values. So we got 5, 7, 15, and 44. And that's it. You guys can do number 2. All right, 3, 4, and 5, we need to tell whether the pairing is a function or not. All right, so let's look at number 3 here. 1/2 is going to 0, 2/3 is going to 1, and 3/4 is going to 3 and to 5. Okay, so here is our problem here, guys. This is not okay. All right, remember I said, think about this as a, the price scanner at a grocery store. It's not okay for two items at a grocery store to come up two different prices. Okay, so this would not be okay because 3/4 is coming out of our function as 3 and as 5. This is not a function. Well, let's look at the converse of that. So is it possible for multiple items at a store to be the same price? Yeah, of course. I mean, think about the dollar store. Everything's a dollar. So, and that's not a problem, right? But it would be a problem if something is a dollar for somebody and $10 for somebody else. So this is a function. You guys can do number 5. Number 6, describe and correct the error related to the function represented by the table. Okay, so it says that the pairing is not a function. One output is paired with two inputs. One output is paired with two inputs. Okay, so they're saying that this breaks the function because we have 1 going to 6 and 4 going to 6. Again, that is not a problem. What would be a problem is if we later on in our table we had 1 going to a different number than 6. If we see that 1 goes to 6, 1 can only go to 6. 1 cannot go to 8. So this would break the function. Having having multiple inputs go to the same output, that is not a problem. Okay, so that was their error. Number 7, draw a mapping diagram for a function with 6 inputs. Okay, so why don't we do this? How about we don't overthink this because we can make this whatever we want. So my x values are going to be 1, 2, 3, and 4, and my outputs are going to be 0, 0, 0, and 0. And can I make a table? There it is. Can I write a rule for this? Well, sure. How could I make this statement true? Well, if I took x, my x values, and I multiplied them by 0, this would work out, right? If I plug in 1 for x, well, that's 1 times x, or sorry, 1 being x, 1 times 0 is 0, making y 0. 2 times 0 is 0. Okay, so there we go. I'll let you guys do number 8. Write a table for the function and identify the range of the function. Okay, so why do they say only the range? Because the domain is already given to you. So again, we're going to make a table. You've got your x values and your y values. Your x values is your domain. So they already gave you that part, 12, 15, 22, 30. And then you just need to figure out the corresponding y values. So we just plug them in. Y is equal to 12 plus 3.5, which is 15.5. And then we go on to the next one, right? Now 11 is equal to 15 plus 3.5. And we just go from there, okay? You guys can finish out that table. Next one here. Same thing. X, Y. They gave you the domain, which is your X values. Go ahead, plug them into the function. So when I input 4, y is equal to 1/2 times 4 plus 3. I just simplify on the right side. 1/2 of 4, or 1/2 times 4, is 2. Drop down that 3. We get y is equal to 5. Okay, and then you start over. You plug in the next x value. 1/2 times 6 plus 3, and you solve from there. You guys can finish out that table. Same thing with 11. All right, and I think the last one you guys have here is write a rule for the function, okay? So remember to keep this from x to y. So how do we go from x to y? You don't want to go this way, otherwise your rule is going to be wrong, okay? So let's see, how do I go from 15 to 7? Well, let's see, we're going from a larger number to a smaller number, so we're probably either multiplying by a fraction or dividing or subtracting. Might be as easy as that. So it might just be taking our x value and subtracting 8. Let's see if that works out. It does for the first one. Does 20 minus 8 equal 12? Sure does. What about 21 minus 8? Does that equal 13? Yep. 30 minus 8, 22. Okay, this checks out. There's our rule. Easy as that.